continuous probability density function. Everything we dealt with so far was discrete. So what about if your function is a continuous? What does that mean, continuous? When we said discrete before, we're saying how many students take in the class. The number of students is always a whole number, like 5, 7, 9, 12, 13. What about problems where the number is not always 1, 9, 7, 14, 15? Let's say you're measuring the length or the amount of water we got in the rain. What was it, yesterday or the day before we had a heavy rain? Was it yesterday? The day before. We had all that heavy rain. If we said, how many inches of rain did we get in Springfield? Well, you might get what? 1.2 centimeters, 3.4 inches, 2.15. It depends how you measure. So that's not a 1, 2, 3, 4, 5. You can have a decimal value. Or if you're measuring the length of, in physics, we do an experiment sometimes. We drop an object, we said take the distance from this dot to this dot, measure them, and divide by the time. That's your average velocity. Well, I can give the same tape to 6 people and I get 6 different results. One will say, oh, that's 3.2. Oh, that's 3.15. Oh, that's 3.2, 3.1, 3.07. So that's what this continuous probability, you can have a decimal value for an answer. It's not always a 1, a 2, a 3, a 4, a 5. So how do you find the mean? How do you find the standard deviation? How do you know the function is actually a valid function or not? Well, if you recall when we did discrete, we said if I gave you this probability density function, and you probably saw that on the last homework and the last test. For x is 0, we got 0.2. For x is 1, we got 0.3. For x is 2, we got 0.4. 4, 6, 9. For x is 3, we got 0.1. I said, is this a valid density probability distribution table? And to validate that's yes, a valid probability distribution table or not, what did we do? There was 2 conditions we had to satisfy. Anyone knows what the 2 conditions are? Each one of these has to be between what? 0 and 1, yes. And the sum of them has to be what? Equal to 1. These are the conditions. If you calculate all these, add all these, probably the sum has to be 1. Well, now we're going to deal with continuous probability density function. So a continuous, I might have a function that looks like this. F of x and it might be something, I'm just making an example like this. It's an integral of some expression. 1 point, I don't know, 25 1 minus x to the 4th dx. This could be the thickness or the size of an opening in a hole there. You measure that, and what is actually that opening? Is this a valid continuous probability density function? That's the first question. And to prove that's a valid probability, continuous probability density function, you need to make sure what? That if you integrate this from negative infinity to infinity, the sum has to be what? What do you think the answer should be? 1. Let me give you limits for that function. Let's assume this function is good for x between 0 and 1. And 0 otherwise. So is this a valid continuous probability density function? Now if I go and graph that, that's x to the 4th. If you have a graphing calculator and you graph that function, it will look something like this. This is the 1, this is the 0, this is the 1.25. Is this a valid density function? Well, to prove that, I got to integrate that from negative infinity to infinity. So let's go ahead and see if that integral equals to 1. If it is, that's a valid density function. Let's integrate. Now we'll take you back to calculus. You got to integrate from 0 to 1 because your function is only good from 0 to 1. 1.25. 1 minus x to the 4th dx. How do we integrate this? We can pull out the 1.25 outside the integral, right? And if I remember my calculus 1 or calculus 2, this is calc 2, integration is calc 2, right? This will be what? X minus the integral of x to the 4th is x to the 5th over 5 from 0 to 1. You plug in your upper limit minus your lower limit. If you remember from calc, that's f of the upper limit minus f of the lower limit. So when x is 1, that's 1.25. 1 minus 1/5. Minus when x is 0, it's 1.25. 0 minus 0. That's 1.25 times 0.8. Is that a 1 when you multiply them? So that is a valid density function. Now, if you want to find the probability, once you establish that's a valid density function, so first we have to make sure it's a valid density function. Sometimes actually I play sneaky because I really don't want to think about a problem. So I'll just give an example. When I make these questions for homework or test, I'll show you what I do there. You go, wow. He's smart. Not really. I cheat. Pick a problem. What do you want x to be? There we go. X what? First, second, third, fourth, fifth, whatever you want to. Pick any x to any power. Reasonable.
Third.
X to the third. You want plus or minus?
Plus.
Plus. Pick another one. Constant, x, x squared, x cubed, x to the fourth, whatever you want it to be.
1 over x. X to the negative 1.
X to the minus 1. Oh, you got a problem now, but you can. Because what's the integral of x to the minus 1? The natural log?
Yeah.
Let's pick something reasonable.
E to the x.
E to the x?
We substitute it.
Okay. And give me from where to where. X between what and what you want it to be. Pick any number.
110.
1 to 10 and 0 otherwise. So what I do, I say, you know what? Let's put a k in the front. Now, right now, I'm not sure if this is a valid density function or not. I didn't integrate it. By putting a k there, I can turn it to a valid density function. So I might say to you, find k that will make f of x a valid density function. So I can take any function and make it a valid density function. He says, how did you come up with 1.25 on the previous one? So it doesn't really matter what function we use. So to be a valid density function, if I integrate this from 1 to 10 here, of k times x cubed plus e to the x, that should equal to what? To 1. And you can work the problem backward to get the value for k. Take the k outside. What is the integral of x to the third? The fourth over 4. Plus, what's the integral of e to the x? e to the x plug in 10 for that. That's 10,000 divided by 4. What's that? 2,500? E to the 10 minus 1 over 4 plus what? E to the 1 I can factor a k out. 2,500 minus a fourth, 2499.75 plus e to the 10 minus e. What does k will have to be? 1 over, it's going to be a tiny, tiny value. That's what k should be. You make k equal to that number, you just turn that function into a valid density function. So when I'm making a problem on the test, if I don't want to think about it, I do the problem backward like this, and I get the answer. Boom, right there. The good news is, that's where my calculator comes in handy, the TI-89. You want exact answer or you want approximation? Exact. F18. Approximate. So you go to mode first, and you make sure you are in approximation mode. The 84 does that, by the way. You don't have to have a fancy one. This is an exact right now. Oh, escape. Oh. Mode. That's not it. Is that approximation? Yep, it is an approximation. Can you see it on the screen? Is that approximation? Flickering? Yep. Watch how nice this calculator is. You want to integrate this, so you can pull the k out to go, what is the integral? So F3. Now you're going to find out there's no reason for you to take Calc 1 and 2 because this calculator does everything, double and triple integral. I want to integrate. That's option 2 for integral. I want to integrate, I like parentheses, I'm a fan of parentheses, x plus e to the x. Where's my function e here? Third e.
Wait, isn't it x cubed?
Oh yes, I forgot the cube here. So let me come back here. X to the power of 3 plus e to the x.
Didn't you just raise everything to x to 3 plus e to the x? I think
Nope. Nope, that's fine. I got to put comma now. Integrate with respect to x. That's what the comma tells you. Comma from 1 to 10. Close that. Now if I hit enter, it should write that problem for me, gives me the answer. The integral from 1 to 10 of x to the third plus e to the x equals 24523.5. If you go exact there, mode, and you want to see the answer we came up with, redo the problem. E to the 10 minus e plus 9999 divided by 4. You'll see when we start doing double integral and everything, that becomes like, ooh, there's the answer. I don't have to spend time, nothing. Much quicker. So you could divide 1 over that number, that'll give me what k is. So a lot of times when you see the answers from me on a test, I'm using this guy. I'm not doing it by hand, you know. And I'm really good with calculus. I can integrate, I can take derivative, but I'm not stupid. I'm going to let the calculator do it for me. So now, if you want to find the probability, given this a valid density function, and remember, if you want to find the probability of x between A and B, it really doesn't matter if that's equal or not equal to, because remember, in integration, when you take the integral of something, what are you actually finding? Think of calculus. What's the integral gives you?
The area.
The area. So if you include that number or not, because that's that line, what's the area of a line going up and down? Zero, has no thickness. So if there's an equal sign or not, doesn't change your answer. That's the integral from A to B of f of x dx. That's how you find the area between A, or the probability between A and B. If you want to find the probability that x is less than or equal to A, again, or x is less than A, what do you integrate from where to where? Yes, from negative infinity to A of f of x dx. If you want to find the probability that x is greater than or equal to A, greater than or equal to A, you're going from where to where? From A to infinity f of x dx. Now let's go back to the previous one we just did here. I gave you, not this one. Okay, I'll go back to this one. I'll wait till you finish writing. This turns to a lot of calculus now. Did it freeze? Oh no, I thought it froze. If it's recording, it doesn't freeze. Okay, so here's the function. Again, I'm using this function. I got to get an answer for this number. What is that number equal to? 1 divided by that answer equals. Oh, let me get an approximately. Mode. I came up, well, no, that's not right. Where was it? 1 divided by
I think you're dividing by the...
oh, the wrong one. Yep. 1 divided by, where is it? Up there. This one.
You need that parenthesis.
Yeah.
Oh, parenthesis, yeah. But it should know, actually. Okay. Clear. 1 divided by parentheses. Where is that number? Keep going. Is that it?
Yes, that one.
Close parentheses, order of operations. Here's what k should be. 0.000041, which is 41 micro. Micro is 10 to the minus 6. So given that function, it's 41 micro times x cubed plus e to the x, and we said this is good when x between what? 1 and 10? And 0 otherwise. What is the probability? And whatever that story is, I mean, I didn't give you a story. That could be what? Let's make up a story for this. Impact of a car. When they collide. When a car hits you, how long the impact lasts? Well, that says small here. Or let's say you know what? That's a small number in the microsecond. Let's say a bat, the ball hitting the bat in baseball. That impact is a quick time. And that's what this function represents. So So what's the chance the impact will be less than, we had it from 1 to 10, was it? Will be less than 6 microseconds. Less than 6. So how do we find the answer to this? We're saying it's between 1 to 10 microseconds. That's the impact between the ball and the bat. Very short time. It's actually in the milliseconds, not really in the micro, but we'll exaggerate a little bit there. Let's say microseconds. So what's the chance the impact is going to be less than 6 microseconds? This will be the integral from where to where? From 1 to 6, 41 micro, x cubed e to the x dx. That would be 41 micro. You can take that out. That's a constant. From 1 to 6, x cubed plus e to the x dx. So let me integrate this on my calculator. I'll cheat again. F3. Integrate that one. There's my calculator. Can you see it? Yep. I'm going to do bracket x to the third plus e to the x, close that, comma, with respect to x, comma, we'll say from 1 to 6, 1, comma 6. Give me the answer of that. K is still sitting in the front. So that will be 0.00041 times 724.461. Which is 0.0295.
Is that a time, or is that just the probability that it'll be less?
That's the probability. That will be less than, 6 seconds. Now, if you want the chance, the probability that the time will be greater than 0.5 microsecond. What's the chance the impact time between the bat and the ball? What's the probability that impact will be more than 0.5 microseconds? So that will be what? 41 micro times, not 0.5, more than 5 microsecond, because our number from 1 to 10 micro, right? So it's going to be from 5 to 10, x cubed plus e to the x dx. Again, I can go to my calculator there. I can even do it better this way. I just go to the one I just did here, hit enter, and change my limits. That's 5. And the other one is what, 10? Two, 4, 2, 2, 1. So times 41 micro. 41 e to the power of negative 6. 0.993. The probability the impact time will be 5 microseconds or more. It's almost 100%. You have a 99% chance that the impact time will be more than 5 microseconds.
So on the one above it, that shouldn't say microseconds, right?
Well, that's the number micro.
No, right below the 0.02.
Here? Oh, no, that's not the probability. Yeah, that's the probability. The impact will last. Yeah. The impact will last less than 6 microseconds. A very small chance. I mean, if I graph that function, we'll see probably that's why it's a small value. If you graph that function, just x, you know what, I'll graph, well, no, not on this one. I don't have to graph on this one, it's too much, too complicated for me. I can graph on the TI. X cubed plus e to the x, if I graph that, y sub 1 equals x cubed plus e to the x, where's second, and let me graph it, window. I want x to go from 1 to 10. And look what happens. You're looking for the area under. So when you look at the area less than, let me zoom in more on the y value. Instead of 10, because my number was multiplied by a small value by 0.41, 0.00. Let's go this one like 1,000. Y max 0. Let's see what the graph looks like. That looks better. So notice for 6 seconds, or 5 micro, 1, 2, 3, 4, 5, 6, we're talking about that area under that. But when you go beyond that, it's much bigger area because the function is rising way higher there. That's why the probability to the left, less than 6 micro, is really a small number. But to go beyond the 5 microsecond, that's almost the whole thing.
But it's 0 after 10, though, right?
Correct. 0 before 1, 0 after 10. Because the function is 0. Yeah. So that's how we find the probability of some of these events. Let me see if I can get another function here. Now, if you want to find the probability between like 5 and 7, then just change the limits to 5 and 7. I don't think I'll do 1 on that. Just reintegrate that. How would you find the mean for that? Now, to go back to discrete, to this one, because that's why I like to go back to this. How'd you find the mean for a problem like this? Remember, anyone?
Is it you multiplied p and x?
Correct.
Times.
The mean was the summation of what? X times p sub x. Well, continuous summation becomes what? Integral. And p becomes f. The integral of f, x times f of x. So to find your mean when you have a continuous function, we'll talk about the standard deviation in a second. So to find the mean, it is the integral from negative infinity to infinity of x times f of x dx. And while we add it, that was a long way to find the standard deviation. We just never did it there. We said sigma, the standard deviation, was the square root. The square root of what?
X minus the mean all squared.
It was x squared times p sub x, yep, minus mu squared, right? Well, this is the same thing, the summation here. So with continuous, this is going to be the summation. This will be the integral of x squared times f of x minus mu x squared.
So we apply the square root after we take the integral?
Yep. If you don't take the square root, that's the variance. That's sigma squared. So what is the equation now for I'll do the variance here, then if you want the the standard deviation, you take the square root of that. So the standard, soon enough we're going to be dealing with joint density, it'll be x and y, that's why I'm putting x's here. It's going to be the integral. Again, this is the variance, that's without the square root. If x squared times f of x dx minus mu x squared. You want to find the standard deviation, then you take the square root of that. Let's go back to the example we did early today. The first one I did today, I had f of x equals 1.25, what was it, 1 minus? Oh, x to the fourth, right? dx, and that thing was x between what, 0 and 1? Was it 0 and 1? Yes. This one. And 0 otherwise. And I want to find the mean, and I want to find this